Hello everybody, I welcome you all to NCAS Geology class. Today I will discuss about magmatic concentration. It is one of the process of formation of mineral deposits. So let us start. Magmatic concentration involves the deposition of minerals from concentration of magma or lava. So what is magma? Magma is essentially a hot silicate melt. A hot silicate melt which is rich in SiO2, L2O3, FeO, Fe2O3, MgO, CO, Na2O, K2O, TiO2, P2O5. So these are the major components which constitute the magma, and there are other metallic and non-metallic compounds and volatiles which are present in magma, and therefore magma undergoing cooling gives rise to ionic mineral deposits under favorable conditions of crystallization. And this magma intrudes into the upper crust of the earth, and under suitable conditions of cooling and crystallization it gives rise to different types of mineral deposits. And what are the different processes that are related to magmatic concentration? The processes are gravitative settling, fractional crystallization, gaseous transfer, liquid immiscibility, filter pressing. So these are the mechanisms by which magma undergoes cooling and concentration of mineral deposits, or it undergoes cooling, and by these methods different economic minerals produced by magma are found to be concentrated in order to give rise to economic mineral deposit. And magma presents the following stages of mineral formation. What are they? These are the orthomagmatic at high temperature from 700 degrees centigrade to 1500 degrees centigrade, which is the early stage of magmatic cooling. Then pegmatitic and nematolitic phase, which is above 575 degrees centigrade. And pyrometasmatism between 500 to 800 degrees centigrade, and hydrothermal mineral deposit ranging at temperature below 550 degrees centigrade or 500 degrees centigrade. The major metallic mineral deposits originate in orthomagmatic stage, which is at a high temperature phase of mineral cooling or magmatic cooling. The mineral deposits which are produced by magmatic concentration are magnetite, ilmenite, chromite, chalcopyrite, pyrrhotite, pentlandite, millerite, diamond, monazite. Mostly the spinel group of minerals, ilmenite and sulfides. Based on time of formation of mineral deposit, the magmatic concentration has been divided into early magmatic stage and late magmatic stage. So early magmatic stage refers to the formation of the minerals before most of the silicates begin to crystallize. And in late magmatic stage, the metal minerals get concentrated after the formation of silicates. And the early magmatic concentration is divided into three types, and late magmatic concentration is divided into four types. Early magmatic concentration. During early stage of magmatic cooling and basic magmas, the oxides and sulfides of iron, nickel, chromium, titanium, platinum get concentrated to give rise to their deposits either simultaneous with the formation of host rock or earlier to that, because of which the name is early magmatic. When they form simultaneously with the host rock, they can be called as the ore facies of igneous rocks. Batman has classified the early magmatic deposits into three categories such as dissemination, segregation and injection. So these are the three processes by which the earlier minerals produced from magma are found to be concentrated, and the concentrated mineral deposits form economic mineral deposits. So what is dissemination? At the term indicates the deposit involves formation of minerals distributed here and there within the magmatic body. It is a process by which mineral deposit is found to be sporadically distributed within the host rock. The region may be their low molecular concentration in the magma and early formation in magmatic body. Because of the low concentration, they are not available at each point within the magmatic body, and few centers of crystallization are being produced, and there the mineral is being produced. So they are found to be distributed here and there within the magmatic body, or it is found to be in disseminated form. For example, formation of diamond in kimberlite. Diamond is made out of carbon. Carbon concentration in magma is found to be very low. So diamond forms from carbon and its concentration in magma is very low. Therefore, the in situ magmatic body, where it occurs, it crystallizes out to form disseminated deposit, or diamond occurs in disseminated form, in irregular here and there. The deposit is found to be there, and that's why it is a dissemination deposit. So dissemination is related to the concentration of the components in magma and their early formation, and their distribution is erratic because of the low molecular concentration and few centers of crystallization. For example, we have the diamond bearing kimberlite pipes. Kimberlite pipes are the host for diamond. For example, Ajrakarur kimberlite pipe of Andhra Pradesh, kimberlite pipe of diamond in Majgaon, Madhya Pradesh. This is Majgaon. So that is in Madhya Pradesh. So in dissemination we find the formation of diamond in kimberlites. Similarly, we have the diamond pipes of South Africa, uranium deposits in Singhbum granite, Jadugoda mines, ilmenite magnetite disseminations in South India. So these are some of the examples of the early magmatic dissemination deposits. Then we have the segregation deposit. Here we find the segregation of the early formed minerals in form of layers, or it may be due to magmatic settling or heavy mineral settling. So it is a process in which early formed crystals or minerals are found to undergo gravitative settling in the in situ magmatic body. This leads to accumulation of denser, heavier minerals at the bottom of the magmatic body as layered or stratiform bodies, which form economic mineral deposits, as we find in case of chromite. Magnetite chromite deposits of South India, Sukinda chromite of Jajpur district of Odisha, Nausai chromite deposit of Keonjhar district of Odisha, chromite of Bushveld complex of South Africa, magnetite ilmenite deposit of Skjergård intrusion of Greenland. So these are some of the examples in which the economic mineral deposits have been produced by settling of the heavier minerals at the early phase of magmatic consolidation, so that the settling leads to concentration of economic mineral deposits in form of layers or in form of stratiform or stratified deposits. So beside this process we have the injection method of the magmatic concentration, where the metallic concentrations in magma do not crystallize at their own place of occurrence or where the minerals are being produced within the magma. There itself they are not found to be concentrated, rather they are found to be squeezed into the country rock along fracture planes, shear zones, fissure planes, joint planes or irregular tracks, which are common features in the country rock at the roof regions of intruding magma. When the magma is intruding, it is intruding with a force. So the roof regions are found to be cracked, jointed, and the early formed minerals, they are found to be squeezed into these cracks, or they are found to be injected into these cracks. So there the injected minerals, they get concentrated in the cracks or they form injection deposits. It takes place because the magma which is undergoing cooling and consolidation to produce these minerals, during the formation of these minerals, the whole system is found to be disturbed or compressed or squeezed, as a result of which these economic minerals, they get pushed into the country rock. In this manner, they get into the country rock and form injection mineral deposits. So the cracks which are common to the roof regions of the magmatic bodies, they become the site for accumulation of these injected minerals. The injected minerals form lenses, veins. This type of origin attributed to some kind of disturbance in the magma chamber, as a result of which crystallized mineral components are forced to change their place of origin either into the host igneous rock or to the overlying country rock along planes of weakness. This process of mineral formation is called injection, as the crystallized components are found to be injected into the country rock or injected into the host igneous body. For example, we have the Vanadiferous magnetite deposit of Dubla-Vera, Singhbhum district, Bihar. Here the host rock is the ultrabasic and gabbro. Magnetite deposit of Kiruna, Sweden. So these are the injected mineral deposits which developed in the early phases of magmatic cooling and consolidation. Then we will discuss about the late magmatic concentration, where the mineral deposits takes place within the magmatic body after the formation of most of the silicates or towards the late phase of magmatic cooling and consolidation. So here the pyrogenetic minerals which crystallize towards the late phase of magmatic cooling and consolidation become rich in silica, alkali, water, titanium, iron, tin, beryllium, lithium, niobium. So these are the elements which become rich towards the late phase of magmatic cooling. According to Batman, the late magmatic mineral deposits are classified into 4 types. 2 as residual liquid segregation, 2 as immiscible liquids segregation and injection, 2 in residual stage, 2 in immiscible stage. So residual liquid segregation, residual liquid injection, immiscible liquid segregation and immiscible liquid injection, these are the 4 processes by which late magmatic concentration of mineral deposits take place. Let us discuss residual liquid segregation first. As the term indicates, segregation it refers to accumulation of minerals. So certain types of basic magmas undergoing differentiation, such as those which yield anorthosites, nurites, gabbros, they may become enriched in iron and titanium towards the late phase. The residual liquid may drain out or get segregated from the crystalline interstices within the magmatic chamber and may form deposit parallel to any igneous structure that may be present in the host rock. So there will be segregation of mineral components along suitable igneous structural planes, or accumulation of these minerals along suitable planes, such as titaniferous magnetite deposit of Bushveld complex, South Africa, titaniferous magnetite deposit of Hassan district, Karnataka. The host rock is amphibolites and basic sheets. Then vanadiferous magnetite deposit of gabbro, anorthositic rocks of Similpal, Mayurbhanj district of Odisha. So here it is, the host rock is gabbroic and anorthositic, and mineral deposits are magnetite. So these are late magmatic segregations or residual liquid segregations. Then residual liquid injection. So here the residual liquid will be injected, where residually produced minerals are found to be injected into the contract, like that of injection in early magmatic deposit. So this is a process of formation mineral deposit in which the residual magma left after the formation of early silicates get disturbed by magmatic or tectonic activity and get injected into the host rock or overlying country rocks, where it gives rise to residual injection deposit. It is found that residual liquid is rich in iron and therefore it forms magnetite mineral deposits in form of dikes as cross-cutting bodies or in form of seals as parallel bodies within the host rock or within the overlying country rocks. So here injection of the residual mineral deposits take place either into the country rock or into the host igneous rock. As the stage involves late magmatic stage, most of the silicates have been produced. So within these silicates, within the interstices, the early magmatic or the minerals which have been produced, they are found to be squeezed. The squeezing takes place due to disturbance in the magmatic chamber or due to tectonic movement to which the magmatic body is subjected to, as a result of which the crystallized components as late magmatic stage minerals are found to be squeezed into the country rock or overlying rock along suitable planes of weakness. Example, magnetite dikes, rocks of Kasipatnam, Visakhapatnam. The host rock is Charnokite, gneiss and metamorphosed wall rocks. Titanium Titaniferous magnetite deposit associated with the basic igneous rocks of Adirondack region, New York. So these are some of the examples of residual liquid injection deposit. Similarly, we have the immiscible liquid segregation and immiscible liquid injection. In some cases, the magma becomes rich with sulfide, as a result of which sulfide layer and silicate layer they get separated out. And from these separated phases, the minerals are produced and found to be segregated. As we see in case of the mixture of oil and water, oil floats on water. Similarly, in case of the magma which is rich with sulfides, there are two layers, sulfide layer and silicate layer. Silicate layer will come to the top with sulfide layer at the bottom. So, magma generally forms one phase, but in some cases when cooling and concentration of magma proceeds, certain components get enriched in magma and immiscibility develops as seen between silica and sulfides. Similar to oil and water, which separates out as two layers, two phases. It is seen that sulfides of nickel, iron, copper are soluble up to 7% in basic magma. So, upon cooling of magma towards the late phase, their concentration increases and finally the sulfides separate out as immiscible liquid layers from silicates. These separate layers through cooling give rise to segregated deposits, that is, a sulfide layer at the bottom of magma chamber and towards the top the light silicate layer. Thus, sulfides remain in liquid at the base of the magma chamber till the overlying silicates have crystallized out. Finally, the sulfides crystallize out as segregated immiscible liquid deposits. So silicates crystallize out on the top first, followed by the formation of these sulfides which come at the bottom of the magmatic body. Example, copper deposit of Singhbhum, Jharkhand associated with the minerals, the associated minerals of pyrrhotite, chalcopyrite, pentlandite. Similarly, lead, zinc, copper sulfide deposits of Hesatu, Belbathan belt of Bihar. They are associated with basic sheets. Then immiscible liquid injection. Immiscible liquid layers of sulfide that accumulates at the bottom of the magma chamber. When phase disturbance tectonically or subsidence of the magmatic chamber, the layer is squeezed out into the regions of low pressure before consolidation as injection deposit. This intrudes into the older rocks and may enclose brecciated fragments of host rock and fallen rocks. So, the two layers, sulfide layers and silicate layer, which may be injected into the country rock, where the sulfide minerals get concentrated as injection mineral deposit. Example, nickelferous chalcopyrite packets associated with altered basic sheets of Singhbhum copper belt. Sudbury nickel ores of USA. So, these are the different processes by which the magmatic minerals are concentrated either in early stage or in late stage through segregation, dissemination and injection methods of magmatic process. So this is the disseminated deposit, where sporadic occurrence of ore deposits are there, including dissemination. Here mineral deposits showing segregation, accumulation in formal layers, as we find in case of chromite, commonly in case of magnetite or platinum group of minerals, PGA group of minerals, or we may find injection when the magmatic body is being disturbed. So into the contour of the minerals are squeezed, so they form injection mineral deposit. So this is all about the magmatic concentration of minerals.